Okay guys, Dr. Darbro here. We're going to look at a problem called hypothesis testing for mean, and I found this example to be pretty cool, kind of a good motivation. So there's a skier who's trying to decide whether to buy a racing wax, and he's only going to use the racing wax, or he's only going to purchase the racing wax if we can show statistically that he can complete a course in less times on average than it's taken previously. So the important things here are he's decided that the wax would be worth the price if he could average less than the 55 seconds, which apparently is the average time that he completes the course. So he goes out, takes 8 measurements, and the measurements are provided right here. So ultimately, guys, what we want to do is we want to be the statistical expert here and determine whether or not he should buy the wax. So what are going to be the steps? Well, the first step, well, actually, let me back up here. The first step is let's enter the data in our calculator. The second step state the hypotheses. The third is going to be calculate our test statistic and p-value. Our fourth is going to be to make our decision. And our final will be to calculate a 95% confidence interval. So gang, there's the game plan, so let's get it going. I'm a step ahead of you. I've already gone ahead and entered the data into L1. So you know what I'd like for you to do is just pause the video, pick up your calculator, or you can do this on R2, but probably pick up your calculator and enter the data. So pause it and come back. Alright gang, first thing we want to do is it's done, entered our calculator, entered our data into our calculator, I should say. So part number 1 done. Guys, the next thing we're going to do is we're going to officially state what we want to test. So got to go back to the problem. I forget. He's averaging 55, but he wants to see if he can do it in less than 55. So therefore, our average is currently 55 seconds. And he wants to see if there's evidence after using this wax. If there's less than 55 seconds. Guys, I see no reason to test at anything other than 0.05. So let's go to step number 3. Alright, step number 3, as we said, calculate our test statistic and p-value. Well, what I'm going to use the calculator for here is to get my basic descriptive statistics. So I'm going to go to Calc, one variable stats. I've got my data in L1. I want my frequency list to be blank, and I want to go to Calculate. Now, the things of interest to me here are the sample mean, which is 53.1, the sample standard deviation, which is 7.029, and our sample size, which is obviously equal to 8. So I was stuttering a little bit there just because, you know, that's what I do, but I was stuttering because I was writing down the information on the chalkboard. So guys, what I want to do first is I want to calculate the test statistic. So our test statistic, we're conducting what's called a t-test. So our test statistic is a t-statistic. And it is calculated by this formula. So guys, our x bar is 53.1 minus the claim of 55 over our standard deviation of 7.029 over the square root of 8. Now I'm going to go to the next page here. First of all, I'm going to put this in, go back and put it in my calculator. So guys, in this situation, we've got to be very, very careful that we use enough parentheses. So the numerator needs to be in parentheses, and the denominator needs to be in parentheses. Uh-oh. There we go. So our test statistic in this situation is negative 0.7645. So this is our test statistic. Now, to calculate our p-value, what we have to understand is the underlying sampling distribution is the t-distribution with degrees of freedom n minus 1. And the p-value is calculated by taking the test statistic and finding the area to the left of that. Now, if you think about what we're conducting here, this is all a function of what is in the alternative hypothesis, what sign is in the alternative hypothesis. We are testing less than. So all of our rejection region goes in the left tail. If we were testing greater than, then all of our rejection region would be in the right tail. If we're testing not equal to, that's a completely different situation that I'll teach you in a future video, or at least someone will teach you, where we put our rejection region in both tails. But, and I'll formalize this in another video. But for right now, what we need to do is find the area to the left of negative 0.746 in the t-distribution, degrees of freedom equals 7. Well guys, the way we do that is we go to our calculator and we go second function distribution. Come down to number 6, which is t-CDF. And I want to go from negative V99 because I'm in the left tail to negative 0.7643. I'm sorry, 45. My degrees of freedom are 7. And I paste. Hit enter. And the value that we get there is going to be our p-value. Okay, the reason I'm collapsing here on you is I'm writing the p-value down on my blackboard so I'll have it when I get there. Alright gang, so what we got there is we got a p-value of 0.2348. I don't know why my screen went nuts. Which is greater than 0.05. Which leads to failing to reject H sub O. Now, failing to reject the null is more evidence for the null than the alternative. When we reject the null, we draw a line through the null hypothesis. When we fail to reject the null, we draw a line through the alternative hypothesis. So based on the results of our test, there's more support for the null hypothesis than for the alternative hypothesis. So guys, what's our decision? Step number 4, fail to reject. Conclusion, don't buy the wax. The wax, although it gave us a lower sample mean for the 8 measurements, when we try to generalize this to the population, there's not statistical significance. There's not enough evidence that it lowers the mean from the previously claim of 55 seconds to complete the course. Okay, the next thing I'd want to do is I'd want to calculate a 95% confidence interval. Guys, a 95% confidence interval is going to be our mean plus or minus our margin of error. Which looks like this. So we got 4 things we've got to find. So looks like our mean, forget this, our mean was 53.1. It's hard to make periods. Our standard deviation was 7.029. Glad I checked. And of course our sample size was 8. So the only thing we've got to find is we've got to find our T critical. Now here's what happens in the T critical. And we studied this back in confidence intervals. We've got to find the negative T and the positive T that separates the middle 95% of our distribution. Well guys, the first thing you got to ask yourself is how much is missing? If we take 100 minus 95, we're missing 5%. We need to put part of that 5%, half of it, in the lower tail, and we need to put half of it in the upper tail. So guys, let's go to our calculator. We're going to need to use inverse T. So we need area 0.025. Degrees of freedom 7. And we get a T critical of negative 2.365. So go back to my error server here. You can see that I put in the negative 2.365 for the T critical. Now we found the negative part, but the positive part is just going to be the same except with the a positive sign. So, all right, gang, let's put this in our calculator and get our confidence interval. So I want to clear out here. So I have 53.1. Minus 2.365. Times 7.029. Divided by the square root of 8. Alright, I'm going to go second function entry here because the only thing I need to do in retyping this is just change the negative to a plus. So in other words, that right there just needs to be changed to a plus, and I get the right bound of the confidence interval. So guys, the 95% confidence interval here would be 47.22 seconds to 58.98 seconds. So you can see that the 55 seconds is contained in the interval, which doesn't lend support for the wax being statistically effective, if you will, in decreasing the time taken to run the course. Okay, so there's the confidence interval. So we would say there's a 0.95 probability. This interval contains mu, which is the average time it takes to run the course wearing the wax. So there's not statistically significant evidence that this is lowered from the average of 55 seconds. All right, gang, that's it. Have a good one.